Hi future doctors, welcome to the next class. In this class we will discuss about gravitational potential and escape velocity. So already we discussed gravitational potential energy between two masses. If two masses separated by distance r, so what is the gravitational potential energy means? Minus g m1 m2 by r. Now, what is the gravitational potential? The amount of work done. Actually, we have done some amount of work done to assemble these charges at some separation or energy. So, U by m1 if you write minus g m2 by r. Otherwise, from this equation, if you write U by m2 minus gm1 by r. If you are taking m1 mass, this mass at a distance r at this point p, what is the gravitational potential means? This one now. So gravitational potential Vg is equal to be minus gm1 by r. The amount of work done to bring m2 up to r. Otherwise, if you are taking like this is m2 at a distance r at this point p. So what is the gravitational potential means? Minus gm2 by r. So this is the equation for gravitational potential. Just to understand. So if m mass at a distance r, so at this point p, so what is the gravitational potential means? Minus gm by r, isn't it? So this is the equation for gravitational potential. How they will ask question means. So if this is only, let us assume m1, m2 separated by distance r. So what is the gravitational potential at center of two masses, they will ask. At the time this is center means what is this distance? R by 2, R by 2. Therefore, because of this m1, gravitational potential because of m1 is minus gm1 by r by 2. Next, because of m2, gravitational potential because of m2, that is going to be minus gm2 by r by 2. So what is the total gravitational potential at center means? V naught is equal to Vg1 plus Vg2. That is going to be minus, if it is going to numerator, minus 2g m1 by r minus 2g m2 by r. So minus 2g m1 by r minus 2g m2 by r. What is common? Minus 2g by r is common. m1 plus m2. So this is the gravitational potential, how to calculate because of single mass. So very easily you can calculate. So if you got gravitational potential energy minus gm1 m2 by r, two masses are there with division of r, that is gravitational potential energy. What is gravitational potential means? Only one mass will be there in numerator, either m1 or m2. Next, force means g m1 m2 by r square, gravitational force between two masses. Just these terms are interchanging. Here g m1 m2 by r square, here minus g m1 m2 by r. So this gravitational force they will ask in vector notation. So vector notation means what we will do, every scalar can be multiplied into vector by, can be converted into vector by multiplying a unit vector. What is that unit vector means? R cap. Unit vector definition minus g m1 m2 by r square. What is unit vector definition? R bar by r. Therefore, g m1 m2 r bar by r cube they will write. This is gravitational force in vector notation. This is the gravitational potential equation. So on this, they will ask problems. How they will ask, we will see in problems case. But whenever they are asking gravitational potential, you have to remember this formula. Gravitational potential due to single mass at some distance r. So that equation you can remember. Next, if three masses placed at three corners, three same masses placed at three corners. So what is the gravitational potential at center of this equilateral triangle of each side small a? So at this center, what are all the distances means small r, small r, small r. So gravitational potential due to A, B, C. So what is the gravitational potential due to A at some distance r because of this mass means so VA is equal to minus Gm by r. Same like that VB also minus Gm by r. VC also minus Gm by r. So V naught is equal to VA plus VB plus VC. So you will get minus 3 Gm by R. Now what is this R in terms of A? Already we have discussed. R is equal to A by root 3. Therefore minus 3 Gm by A by root 3. Then final answer is minus 3 root 3 Gm by A. Same like this square, like this they are going to ask. You can do just if you know what is the distance from that mass and how many masses are going to be placed. Same like that we discussed gravitational potential energy also. This is gravitational potential. Next, escape speed or escape velocity. So what is escape velocity or speed? So every object, very simply we are going to discuss every object whichever is going to be placed on the surface of the earth or planet we will take on the surface of the planet, how much gravitational potential energy for this mass means UE is equal to on the earth surface gravitational potential energy is equal to minus gmm by capital R. So this negative sign indicates so this is under the influence of that gravitation. So it is going to be attractive. So it will be available because of this gravitational potential energy. Otherwise, it is going to be escape. Now, even though this much gravitational potential energy is acting to keep that object on the surface of the earth. So if we are going to give some velocity which is equal to this gravitational potential energy in opposite direction, that is going to be so gravitational potential energy should be equal and opposite for given velocity means that is only kinetic energy. So we are giving velocity for this object means to escape from this gravitational influence. So then we are giving kinetic energy. So this kinetic energy should be equal and opposite. Then only it is going to be escape. Therefore, this one we are going to take. Gmm by capital R is equal to half mass of this object mv square with escape velocity we have thrown. So if you cancel this mass, then escape velocity v square is equal to 2gm by r. Then escape velocity is equal to root 2gm by capital R. Very important equation. This is in terms of mass of the planet and radius of the planet or mass of the earth, radius of the earth. If you substitute, you are going to get escape velocity. So we came to know, so G is equal to Gm by R square. Then Gm is going to be Gr square. If you substitute that one here, root 2 by R. So what is Gm means? G R square. R will be cancelled. That is going to be root 2G R. So is it visible? So escape velocity equation, two equations you will be having. So if you substitute this Gm is going to be Gr square here. So one is root 2Gm by R, another one is root 2Gr. Both the equations are given as escape velocity. If you substitute small g value for earth, radius of the earth, you are going to get that value 11.2 kilometer per second. So if any object is projected upwards with 11.2 kilometer per second it is going to be 11.2 kilometers, it should move. Then it is going to be escape from surface of the earth, isn't it? If we are playing with this much velocity, 11.2 kilometer per second, skipping or running, you will be escaped from the surface of the earth. So in this, how they are going to ask the questions, very, very important. If small g is constant, escape velocity is directly proportional to root r. If mass of the planet is constant, escape velocity. If mass of the planet is going to be constant, escape velocity is inversely proportional to root r. Again, small g can be written as small g is 4/3 pi rho g capital R. So, if density of the planet is constant, this is if mass of the planet is constant. If density of the planet is constant, escape velocity can be written as root 2 times of 4/3 pi rho g capital R into R. In place of small g, we wrote this. Then, if density is constant, escape velocity is directly proportional to R into R root r square. At the time, escape velocity is directly proportional to r if density is constant. Density of the planet is constant means if radius of the planet is doubled by keeping density of the planet is constant, then escape velocity also doubles. Radius of the planet is doubled by keeping mass is constant. At that time, it is going to be 1 by root 2. So, those two equations we have to remember very carefully. Escape velocity is inversely proportional to root r if mass of the planet is constant. Escape velocity is directly proportional to r if density of the planet is constant. And escape velocity sometimes you should take according to this equation, sometimes you should take according to this equation according to the given data in the problem. So, that is the equation for escape velocity, and it does not depend on mass of the object. So, 1 gram to 1000 kg, minute particle to heavy particle. So, escape velocity remains same, and it does not depend on angle of projection. See here. So, but escape velocity depends on radius of that planet, mass of that planet. Escape velocity depends on density of that planet and radius of that planet. So, density is doubled, radius is half. What happens? You have to use this formula. Mass is doubled, radius is half. What happens to escape velocity? We have to use this formula. So, very important concept. So, try to remember. So, I hope you people understood. We will see in next class. Thank you.